Okay guys, welcome back. This video is pretty neat. I like this video. In this video, we have fractional exponents and we're going to learn to convert them to roots to simplify. Okay, so we were simplifying roots, now we're going to take a look at some fractional exponents. Well, look at this formula. When you have a to the m over n and you want to convert it to a root, it is equal to the nth root of a to the power of n. So the numerator, the exponent, becomes the exponent for whatever's inside the root. And the denominator becomes the root number, okay? The root number. All right, so let's try this one. Now, here I have a, let me make sure this is clearly the exponent, to the power of 2/3. Well, if I wanted to convert that, my root number would be 3, and I would be left with a squared. Now, do I have enough a's to pull an a out? I don't, so it would stay just like that, okay? All right, now here, let's see, this negative is included because it's in parentheses, all right? So my root number is gonna be 5, and I have, let's see, I have the 5th root of negative 32, so we need to make sure that that negative 32 is in parentheses to the 4th power. Okay, I'm going to erase this one for just a second because I'm going to need to do some work here because I need to simplify this. Now, it'd be awesome if I had enough negative 32s to pull out, but I don't. I don't have enough negative 32s to pull out. Let's break down, this is equal to negative 32 times negative 32 times negative 32 times negative 32. Oh, this is going to be a little messy. Let's see, each negative 32 will break down to, let's say I got negative 2 and 16, negative 2 and 8. How about, or negative 2 and negative 8, because negative 2 times negative 8 is 16. How about negative 2 and 4, and how about negative 2 and negative 2? I mean, you can check all the signs on those, but negative 2 times 16 is negative 32. Negative 2 times negative 8 is positive 16. We didn't break any rules, we're good. Now, let's see, I got 1, 2, 3, 4, 5. So I got 5 negative 2's. So every time I factor down a negative 32, I'm gonna get 5 negative 2's. So I could rewrite each of these as negative 2 to the 5th. Or every time I factor down a negative 32, I'm gonna get a group of 5 negative 2's. So I'm gonna have one of them here. I'm gonna have one of them from here. So it's gonna be negative 2 times negative 2 times another group here, negative 2 times negative 2. And if I multiply negative 2 times negative 2 times negative 2 times negative 2, I get 16. Wow. I wonder, what if we plug that one into our calculator? You think it's going to work? Let's do, in parentheses, negative 32 to the 4/5 power. 16. Wow, that's awesome. Okay. Yeah, that was kind of messy, but I'm going to erase it and put that other problem back up so we can get to everything here. All right, look at this one. Is a negative being applied to that exponent? Be super careful with this. It's not, right? So what I really have is negative, and then I have a root. What's the root number? 4. And then I have 16 to the 3rd power, right? Well, 16 to the 3rd power is really going to be 16 times 16 times 16, right? And if I break it down to 4 and 4, and I break that down to 2 and 2, 2 and 2, each 16 is going to give me a quadruplet of 2's. So basically, I have a group of 2's from this 16, a group of 2's from this 16, a group of 2's from this 16. 2 times 2 times 8. So I have an 8 coming out, and that's going to join this negative, so I get negative 8. And you can plug that one right into your calculator, it'll give you negative 8. Okay, I'm going to erase this here. erase this one here. Let's clean things up a little bit. All right, let's do this practice problem D here. This was x to the 5/6 one. This one's pretty easy. X to the 5/6. Boy, there's nothing really tricky about that, right? We have the root number becomes 6, and x to the 5th. And I don't have enough x's to bring an x out, so I have to stop there. I did erase the one I wanted to do. It was E. E was 3x to the 2/3. So I guess what you want to look out for here is this exponent applying to the 3. It's not, right? So I have 3, and then I would have the cubed root of x squared, okay? And I don't have enough x's to bring an x out, so this would be it. All right, this one's tricky. Oh, you're not gonna like this one. I don't know, maybe we'll. I have a negative exponent. How do I fix a negative exponent? I gotta move it to the other side. So what I'm gonna get is 2, and then this p is gonna go down, this p is gonna go down, and I'm gonna be left with p to the 1/2. Now, what is my root number gonna be? My root number is gonna be 2. So I have 2 over the square root of p. All right, now you guys remember, all right, forget it. Remember rationalizing the denominator? Leaving, we can't leave a square root in the denominator. From geometry, came up a little bit, algebra came up. Well, we're not gonna worry about that right now. I'm gonna say you can leave that bottom radical. That kind of gets me all fired up anyway. When we get to trig, we're gonna do a lot of rationalizing the denominator next semester, so I'm not gonna worry about that right now. We'll leave it as 2 over the square root of p. All right, now, here, this 1/4 is being applied to the entire binomial. So our root number is gonna be 4, so the root, and then I have 3a plus b, and there we have it. 3a plus b is to the first power, so if you really wanted to put in parentheses to the first power, we would do 1, but I mean, since it's 1, you don't need to do it. If it was like squared or third power, you would need it, but for the 1, you don't. All right, I hope you enjoyed that. You all have a wonderful day.